In this video, I'd like to show you how to keep a laboratory notebook. Now, typically we would be meeting weekly in lab together and I'd be evaluating your notebooks through the quarter and giving you feedback. And I would make you use a composition book, something like this. The only one I have at my house right now is actually the one for my kids' kindergarten class. So not this kind, the kind that's just ruled or like a grid. But the trick about it is that it's bound, right? Like I can't tear the pages out without it being extremely noticeable. And that's what you want for a laboratory notebook. You want something that is a complete record of your work in the lab. You want someone to pick it up and be able to know everything that happened, the mistakes, the successes, the failed starts, like everything about what happened in lab. And we want to be able to read it all. So when we take observations and we practice using a laboratory notebook, I know that nothing we're doing is going to have huge consequences for the universe. No one is going to figure out the cure for COVID in this class using a notebook. But we're going to get into the habit so that way when you find yourself in a lab, you are prepared to actually keep a lab notebook that makes it easier to do science and to communicate science. So for this class, we're going to learn these skills and practice these skills, but we're going to let go of some of the things that aren't as important for a learning environment, like having the right type of notebook. You can keep an actual notebook for the class. It might be really helpful and it's kind of fun, in which case you might want to pick up a composition book like this. But you can also just use a spiral bound notebook this quarter as well. It doesn't really matter. I like grids personally, but that's just me. You can also just use pieces of scratch paper as well, and just hand write it out. If you have a tablet with a pen that you can write with, you can also just use a blank piece of paper or a grid template, and you can do your lab notebook on the tablet itself. The trick is it's handwriting. It is not typing, because we need a record of mistakes. And if you're using a tablet, you're going to have to be a little extra careful about this. You're going to need to make sure that you don't erase, that you cross things off with just one line so you can read whatever mistakenly was written down. And that is the key to getting the complete picture of what happened in lab. You want to record everything. If you make a mistake, you want to record that it's a mistake, but you want to be able to come back and read it later. What if it actually wasn't a mistake? Or what if it was actually a really interesting mistake? You just need to know. So use a notebook, use scratch paper, use a tablet. The trick is you're going to show me your mistakes throughout the quarter this time. And if it's really neat and I don't see any mistakes, I am probably going to give you a bad grade on it because I'm like, this doesn't represent what you actually did. Unless you did it all and then you did it all over again, but that's repeating it. I want the first one too and the second one. So I'm going to walk through what needs to be in a lab notebook for any sort of lab activity. I'm going to then walk through an example as well of an elephant toothpaste demonstration. So this document can be downloaded on the Lab 2 page, and it's kind of my basic format for a laboratory notebook. And I'm going to walk through the key pieces of information that need to be part of any lab notebook that you're maintaining for any experiment. First and foremost, you always need to have your name and date. If you're working with someone, you also need to tell us who you're working with. Just like in a lab in industry, you'll need to say who did the work that is going to be represented on this page. Now, the date is key. And if you are actually in a real lab, you not only write the date, you sign every single page. You cannot actually get a patent without having signed all the pages of the experiments that led up to the creation of the body of work that gets the patent. And so what I would typically do is at the bottom of the page or the top of the page, just do a JP and then the date. Like this. But you don't have to worry about that because this is just introductory chemistry. So after, you always make sure that you have your name and date. And we won't be working with lab partners this quarter, but so you don't need to worry about that piece. You always need to make sure you have the lab title or number in this as well. So it's easy to flip through a notebook and be like, oh, we're on lab 2, I can go find that. Typically lab notebooks also have a table of contents in which It's very easy to start a table of contents and then forget to keep filling it in over time, but that's what they need to have so someone can easily get to the page for the experiment that they're interested in reviewing. Now, the rest of this is going to look different for different classes and different types of classes. So I've kind of created a template here for a uh, general chemistry lab notebook. There are changes I would make if this was something where we were going to do organic synthesis. So first and foremost at the top, you're going to want to have a scientific objective. That's 1 or 2 sentences in your own words explaining the point of this lab. Our lab manual has actually a really nice set of examples of good and bad scientific objectives that'll be linked as well on this lab page. But basically, one of the things that's the biggest mistake that's made is students often write a scientific objective about the point of the lab from the perspective of the student. And that's not the scientific objective. That's like the educational outcome or objective of the actual lab. This is from the perspective of a scientist. And so it's what do you learn from a lab that would be useful to an understanding of something scientifically. Usually, I figure out what the scientific objective of a lab is by looking at the post-lab questions and the analysis I'm going to do after I collect data. The introduction won't tell it to you. You really need to look at the lab as a whole and say, like, what is the point of what we're going to do today? Is it to calculate the enthalpy of vaporization for a compound? Is the point to figure out the concentration of an unknown solution? It could be a lot of things. And sometimes some labs will have a couple different points. And some labs are really created to teach you a skill that's still not going to be included in the scientific objective. You can list it. You can say, we are going to, or the scientific objective is to determine the concentration of an unknown solution of hydrochloric acid using titration. And so you can include the skill you're going to be learning, the titration skill, but it's not the point, right? The point is to actually get the concentration of something. So after that, I like to have pre-lab notes. This can be also listed as just notes about hazards as well and safety. So typically these are going to be safety and or waste disposal. This is the type of thing I would talk about at the beginning of our lab. And so safety and waste disposal will come in handy when we're doing at-home labs. When we're doing online labs, there really isn't anything to report. Now, after that, we're going to have space to take observations and to have a summary of the procedure. And so there's 2 pieces here that we really need. We need that summary of the procedure, and we need to have space for our observations while we're actually conducting the lab. And so this observation space should be blank when before you actually start the lab. And the summary of the procedure should be completed before you begin. The idea is when you sit down to do an experiment, you develop a procedure or one is handed to you, you review it, you need to know exactly what you're going to do. And the summary of the procedure are bite-sized pieces of information of steps to kind of remind you of where you're at in your overall procedure. It's not writing down the procedure word for word. It's really just here are the general steps I'm going to take. And the reason for this is you want to be able to link observations to a point in the procedure. And so if I have a list for my procedure, a summary, I could take one of these points, draw an arrow and say, it turned pink. And I don't have to write out while I'm doing the experiment, oh, when I added this to that, it turned pink. I can just put a little line and say pink. And it'll allow me to take notes in a much quicker way while I'm doing the experiment, which allows me to take more observations down while I'm actually conducting the experiment. And that's the point of this. The point is to prepare a lab notebook page so you can conduct an experiment and record as many observations as you can that will be meaningful to the work you need to do with that information later. Now, after the procedure and the observation space, there should always be space for calculations. There should always be space for data tables and graphs and your conclusions. Now, some of our labs won't require a graph, and so we leave that part out. Some won't require a data table or calculations. These are all things that you add if you need them. But there should be space for them before you start the lab, and leave lots of space for them. You don't want to make everything cramped and you don't want to have to squeeze writing in. Take lots of pages. I know it's counterintuitive, but just take lots of pages for this. And the space for calculations could be just leaving a page or a back of a page blank for a place to do calculations. Data tables should be constructed before you begin the lab. So your data tables should have uh, the the labels of what you're going to be tracking and recording information on and what you're going to be recording them for, and have space so that way when you're performing the lab you can just come in and write, oh, it's 32 grams here, and you can write in, oh, but this was 45 grams. And the idea is to be able to, again, write information down quickly without having to do a lot of formatting. So that way when you come back and look at this later, it's easy to find information. It's easy to recreate what happened during the lab in your mind while you're working on it outside the lab weeks later, possibly. And so that's our goal, capture information. Same thing with the graphs. If I know I'm going to need a graph, I'm going to actually put that graph in there beforehand with my labels on my axes beforehand. I might not know what increments to do, so I can leave that out, but I can have the space ready to go. And the idea too here is that I'm thinking ahead to what I'm going to do in the lab and what I need and the information I need. And all of that prepares you to get through the lab easily, to not make mistakes, and to perform it as safely as possible, which is the real goal at the end of the day in an academic lab. Lastly, the conclusions piece is going to be space for you to reflect right after you complete the lab. So a lot of times when we think back, we'll be like, oh, we'll remember this, but we don't. We like it slips from our minds so quickly. So this is an area to actually uh, kind of put down your initial ideas, directions you might want to go later, or questions you had at the end of it. It helps to read the post-lab questions before performing a lab, because then you have them in your mind and you can kind of be looking for hints while you're doing the lab, and you can maybe jot down some notes about them at the end. Well, everything is fresh in your head. You don't have to do a detailed job. It doesn't have to be amazing. It just has to be getting some of your initial thoughts down and impressions. So that way it's easier to unearth those later as you're really sitting down to analyze and reflect on the data you collected. Now, what I want to do is walk through an example of how to set up a lab notebook before going into a lab. Here is an example of a simple lab. It's a demonstration. It's a demonstration of an experiment called elephant toothpaste. And this is the format that you would find a typical lab procedure. We have a title and lab number. We typically have things like materials, an introduction to what's going on in the lab and the hazards that you can expect, and the procedure. There's usually waste disposal at the beginning or the end as well. And then we have post lab questions. So, what I've highlighted in green are things that we'll include in our lab notebook. Other things I'm reading that I see in the introduction might be very useful, like the chemical equation that we're going to be using. I'll probably want to incorporate that. So I have it handy with me while I'm doing my lab. Now, my procedure, I'm going to summarize. My hazards and waste disposal, this will be part of my pre-lab notes. I may want to also include, along with it, some more information that might come in handy while I'm doing the lab, especially if I have to do any calculations. It'd be good to know any chemicals that I'm working with, what kind of molar mass they have, or density for some equations. Sometimes knowing physical properties of our compounds right away when we're in the lab can be really helpful. Okay, imagine that this is an actual bound lab notebook, and here's my binding right here in the middle, and I have 2 pages open in front of me. I'm going to walk through how I would create my lab notebook before performing this experiment. So, of course, I'm going to start with my name and the date. I'm then going to put the title of my lab. So, this was Lab 0, elephant toothpaste. Great. I've like already started making a fantastic lab notebook. Next, I'm going to list my scientific objective. And so when I write this, I'm going to try to write this from the perspective of a scientist and not a student. So I know that I'm going to watch this demonstration about elephant toothpaste, but I'm going to go and look now at the post lab questions to get an idea of what I'm actually going to be doing. So I'm going to come to these post-lab questions for a hint about the scientific objective. Now, I know from my introduction that we're going to be observing a chemical reaction that takes place, and we're going to use a catalyst. We're going to use potassium iodide as a catalyst to make this reaction happen quickly. Looking through my questions, number 2 and 3 are both questions about the chemical reaction that I could answer without watching the lab take place, without doing the demonstration. It's about how potassium iodide acts as a catalyst and how we represent that in a chemical formula, and also how to identify what's being oxidized and reduced um, in the reaction. Which again, I can answer this question without actually doing the demonstration. But question 1, I actually need to see the demonstration to answer. And it's asking, is the reaction exothermic or endothermic? Use your observations as evidence and structure your answer as claim evidence reasoning. So I need to watch this demonstration to determine if this is an exothermic or endothermic reaction. I'm going to use the information collected in the lab to answer that question. So that is my scientific objective. So I'm going to write a scientific objective that states the objective of the lab is to determine if the disproportionation of hydrogen peroxide is exothermic or endothermic. I would probably include the chemical reaction on here too, so that way I can reference it later. So it'll be 2 hydrogen peroxides will disproportionate, aqueous, into 2 waters and oxygen gas. Now that I have my scientific objective, I'm going to write out any pre-lab notes. And so that might be, in this case, hazards or waste disposal. Now there's a hazard section in the actual lab procedure. So I'm going to just make sure I have that information handy while I'm doing my lab by rewriting it here. So hydrogen peroxide is a strong oxidizer. So I would really need to make sure I'm wearing goggles and neoprene gloves when I'm handling it. Those are the only hazards listed. Now I'm going to look at waste disposal. Under waste disposal, I'm told that I'll be able to dispose of the waste in the liquid container in the waste disposal hood. There'll be a container for it. And so I'm just going to say in dispose of all liquid in the waste um, collection hood. Now, in this case, there'll probably just be one waste disposal jug. If you're in an organic lab, there would probably be one receptacle for collecting organic solvents and organic waste, and one for collecting aqueous or water solvent and waste that would dissolve in water. And so you would need to know which contents would go in which one. And this would be the place to write it down. So that way you didn't get confused during the lab and accidentally dispose of a material in the wrong waste stream. Now, from here, I've kind of got the main pieces down. This is typically where I would put information that I might need for calculations if I was in a synthetic lab or a more advanced lab setting. So I'll show you what I mean, but this isn't something that will be one of my expectations for our introductory quarter. But I would probably put a table for the compounds that I'd be working with. So I would have a compound list. So I'll be working with hydrogen peroxide, and I'll be working with potassium iodide and dish soap. I would then probably have concentration if it's in a solution. And so I'll be looking at for our hydrogen peroxide, it would be 30%. For our potassium iodide, I'm going to be using 5 grams, so it's going to be a solid. And our dish soap will be a liquid, and I probably won't know the concentration, so I'll put unknown. And then I'll probably need to know the amounts I'm going to want. And so I would list these kind of pieces of key information, like I'm going to use 5 grams of solid potassium iodide, and I am going to use 50 milliliters of my hydrogen peroxide. And I'm just going to use a little bit of soap. So it looks like I'm going to use 10 milliliters of soap. Then, based on the type of lab, I would probably include physical properties that would be useful. And molecular weight is definitely one of them. And I would list that here. This section might also be useful to have things like density, is one that I've used before, um, or boiling point or melting point, depending on the structure of the lab. But it's basically physical properties that we need. Again, this isn't necessary for our introductory level. I'm just trying to show you if you continue on in chemistry, this is a really good habit to build. Now, after this, we're going to have our procedure, and we're going to have our space for observations. So the style that I was taught and that I personally love is where I create 2 columns within my lab notebook. One for procedure summary and one for observations. And what I typically do is I make sure I have plenty of space for my observations. And my procedure is not rewriting it at all. In fact, it's just summarizing it. So for this one, I have a very small procedure for this. And if you take a look at it while I write this out, I'm just going to kind of highlight things. So what I'm going to do is like I would say I would weigh out or measure out the materials that I would need. So I would need 5 grams of potassium iodide. I'm going to need 50 milliliters. It says dissolve 5 grams of potassium iodide in a minimal amount of water from a 50 milliliter Erlenmeyer flask, or in a 50 milliliter Erlenmeyer flask. So I'm going to need water, but I'm going to try to make sure it's as little as possible. I'm then going to add 10 milliliters of soap and mix. I'm not putting in the details about the mixing or which size flask because this isn't important to the actual experiment or to me being able to follow it. I'll have this procedure with me. These are just benchmarks or for me to take notes based on. And then I'm going to add in some color. And then I'm going to combine all of these. And then I'm going to add 50 milliliters of my hydrogen peroxide. And that's it. So that's my kind of measure, then combine, and then add. So when I go through and do this lab, the way I would have my observations is I would record the exact mass of the potassium iodide in my observation side. I would also list any visual observations that I saw. So then after this, I would have space for calculations. This lab won't require them, but I would list this and have a bunch of empty space. But again, this lab doesn't have any calculations, right? This lab also doesn't have any graphs and it doesn't have any tables that I would need to have. But what I would do is following the space I would leave for observations, I would have places for calculations or space for a table in which I would have maybe I'd be collecting, I don't even know. This one is kind of weird. Maybe I would be collecting temperature. Let's do that over time. And so I would do temperature in degrees Celsius and time. Maybe I would record it every 1 second, right? And I don't know what it's going to be, but I know that I'm going to record at a certain rate and I would record the temperature and I would leave this blank like this. And then when I'm actually performing the lab, I would come in and I would write information in that space. And so it might look something like, well, I'm following, it'd be like, I'd have a thermometer and I'd be taking readings every 1 second. So maybe it's like 25 degrees Celsius, 26 degrees Celsius, 27 degrees Celsius. And this space right here would be filled in during the lab. All right, but this lab procedure doesn't ask us to take any temperature reading, so I'm going to erase this and just leave this blank as per what I'm going to have. I would also, again, create any graphs that I thought I would need. And I might leave space at the bottom for conclusions, so I remember to actually do them. All right, I have my lab notebook set up for this experiment. I'm now going to show a short demonstration video of elephant toothpaste, and then I'm going to record my observations at the same time. Okay, I have just a video demonstration of the elephant toothpaste demonstration, following a similar procedure to the one that we have created. So we're going to imagine we're all together in a room and that I'm doing this for you in person. Here's how I would record information as I did it. So we're going to assume that as this starts, that we already have done this first part right here of measuring and combining. So as I weighed out my potassium iodide, I would record the exact amount. Let's say I got 5.002 grams. Great. And then I'm going to measure the amount of water it took to dissolve it. I'm going to use a graduated cylinder. And let's say I do that and I find out, I'm like, oh, okay, great. This is actually, it was only 2.0 milliliters of water that I added. Then I'm going to add my 10 milliliters of soap and I'm going to record the exact number of significant figures I measured that with. Let's say I measured that with a small graduated cylinder, and I got exactly 10.00 milliliters of soap. So what I'm doing is I'm using this observation area to record the data that I would later use for calculations. For the color for this one, there's not going to be any color. So I'm just going to put like an X. And then I'm going to combine them and add the 50 milliliters. So when I combine them, I might make some observations about the color, that it looks kind of brown or, you know, a little viscous from the soap. And then I'm going to add the hydrogen peroxide. I'm going to record we're using 30% hydrogen peroxide. And I'm going to record the amount that I measure first, of course. So let's say I measure exactly 50.0 milliliters. So here's the soap going in. Oh, it looks like we put in some color. We put in red. So I would make a note about that. And it swirls. So it's a red-brown color. And then in goes the potassium iodide into that solution. And I'm seeing things bubble and I'm seeing things steam and I'm noticing steam. Are you seeing steam there? I'm seeing some wisps of something. So when I do this, I see steam. I see orange foam expand. I see a lot of it. So now he's going to show a couple other ones, which are kind of exciting, especially if you get a narrow neck. It creates quite a large forceful reaction that shoots this up into the air. And the soap is really capturing the gas within it. So I'm going to stop there. Thanks, bearded science guy. And that's it. So I noticed steam. I noticed the orange foam expand a lot, like hundreds of times more volume. Now, if I was actually in the room, I would go up and touch it. I would go touch the glass container. I would notice the glass container is hot. And that's where I'm going to keep all my observations, next to where I did the procedure. And so I can even state on the side here when I combine everything. This is what I see. Now, my conclusions from this right off the bat, just watching it, I would say, you know, this is really surprising. It made so much stuff, but the steam and the warm glass tells me heat was released. So I might make a note about that. And then I would use this later to go and answer that question about if it's exothermic or endothermic. And I would probably say, well, it's an exothermic process because the surroundings got hot instead of cold. And my evidence for that was the steam I saw rising from the reaction mixture after everything was combined. And the glass and the surroundings were warm to the touch at the end of the reaction. And that's why I think it would be exothermic, because exothermic reactions release heat to the surroundings. All right, so that's how you keep a lab notebook, or that's one way I do it. In terms of different formats, some people, instead of doing the procedure and observations the way I have here, instead, they'll do something where they have the procedure on one page on the back of the page and then a whole page for observations next to it. Some people like to do a short paragraph summary of the procedure and then just have open space for observations. This is my preferred method. I even recommend giving it a try before trying others. But the thing that's important is to find a way to keep your lab notebook so it is easiest for you to take detailed and quick observations while conducting an experiment.